different between the two, yung the simplification of the intake and the exhaust strokes in the ideal cycle. In the exhaust stroke, heat Q out is ejected into the environment. In a real engine, the gas leaves the engine and is replaced by a new mixture ng air saka ng fuel. Tas in real engines, the heat addition is never isobaric. Tas wala ding heat transfer kasi sa compression, the gas is compressed adiabatically from state 1 to state 2. In real engines, there are always some inefficiencies that reduce the thermal efficiency. Saka sa expansion, the gas expands adiabatically from state 3 to state 4. Tas dito rin, complete combustion of the mixture. And wala ding pumping work. Yung pumping work ay yung the difference between the work done during the exhaust stroke and the intake stroke. In real cycles, there is pressure difference between the exhaust and the inlet pressures. No blowdown loss. Blowdown loss is caused by the early opening of exhaust valves. Nagre-resulta to ng loss of work output during the expansion stroke. Tapos ay wala ding blow-by loss. The leakage of compressed gases causes the blow-by loss through sa piston rings saka sa other crevices. Saka wala din dito frictional losses. Ang sunod dito ay ang thermal efficiency for diesel cycle. In the thermal efficiency of any heat engine is defined as the ratio of the work it does to the heat input at high temperature. The thermal efficiency represents the fraction of heat converted to work. Since the energy conserved according to the first law of thermodynamics, yung energy cannot be converted to the work completely, the heat input must equal the work done plus the heat that must be dissipated as waste heat into the environment. Kaya pwede nating isulat yung formula ng thermal efficiency sa 1 minus QC over QH or 1 minus heat or over waste heat. Heat input over waste heat. Tapos, the heat absorbed occurs during combustion of fuel-air mixture when the spark occurs roughly constant volume. Since during isochoric process, walang work done by or on the system. Tapos isa-substitute this expression, yung Q CAD is equal to MCP multiplied by T3 minus T2. Tapos yung Q out is equal to MCB multiplied by T4 minus T1. Substituting this expression for the heat added and rejected in the expression for thermal efficiency ay magiging yung thermal efficiency is equal to 1 minus 1 T4 minus T1 is over K T3 minus T2. Tapos yung this equation can be arranged to form with the compression ratio. Tapos yung where N diesel is the maximum thermal efficiency of a diesel cycle. Tas yung CR is the compression ratio, tas yung K is equal to CP over CB or 1.4. Next slide. Tas ang dual cycle naman or limited pressure cycle is a thermodynamic cycle na pinag-combine to ng Otto cycle and the diesel cycle. In the dual cycle, yung combustion nag-occur siya partly at the constant volume and partly at constant pressure. Compared to an Otto cycle, which assumes that heat addition is added partly at constant volume and partly at constant pressure in a dual cycle. Kaya ang advantage is that maraming time na available for the fuel to combust completely. On the other hand, yung the use of dual cycle is slightly more complex. The thermal efficiency lies between the Otto and the diesel cycle. Sa dual cycle, the system executing the cycle undergoes may series siya ng 5 processes. The two isentropic processes alternated with the two isochoric process and one isobaric process. Yung isentropic compression, yung una, yung the gas compressed adiabatically from state 1 to state 2, tapos yung piston nag-moves from intake valve closing point to the top dead center. Yung pangalawang process ay yung isochoric compression or the ignition phase. Yung sa phase na to, between the state 2 and state 3, there is a constant volume, the piston is at rest, and yung heat transfer to the air from an external source while yung piston naman is at rest at the top dead center. Yung sunod na process ay isobaric expansion or the power stroke. Sa phase naman na to, yung between state 3 and state 4, mayroon ditong constant pressure, heat transfer to the air from an external source, combustion of the fuel, tapos yung piston ay moving toward the V4. Tapos yung isentropic expansion or the power stroke, the gas expands adiabatically from state 4 to state 5 as the piston moves from V3 to the bottom dead center. At ang last ay yung isochoric decompression or exhaust stroke. Sa phase na to, the cycle completes by a constant volume process. Tapos yung heat is rejected from the air while the piston ay nasa bottom dead center. During this dual cycle, yung piston ay nag-work on the gas between state 1 to state 2. Yun nga yung isentropic compression. Tapos yung gas works on the piston between the stage 2-3, isobaric heat addition. Tapos yung stage 2-3, the isentropic expansion. Yung difference between the work done by the gas and the work done on the gas is the net work produced by the cycle. Tapos nagko-correspond to sa area enclosed by the cycle curve. The work produced by the cycle times the rate of the cycle, yung cycle per second, is equal to the power produced by the diesel engine. In general, the thermal efficiency of any heat engines is defined the ratio of the work of it does to the heat input at the high temperature. Katulad nung kanina, thermal efficiency is equal to the work over heat input. Tapos, the thermal efficiency represents the fraction of heat converted to work. Since the energy is converted according to the first law of thermodynamics nga, yung energy cannot be converted to work completely. The heat input must be equal to work done, plus the heat that must be dissipated was waste heat. Katulad din sa diesel engine, yung thermal efficiency is equal to 1 over heat input over waste heat. Therefore, the heat added and rejected are given by the Q add is equal to MCB multiplied by T3 minus T2. Tapos yung Q add 2 is equal to MCP multiplied by T4 minus T3. Therefore, tapos yung Q out pala is MCB multiplied by T5 minus T1. Therefore, yung thermal efficiency for dual cycle is thermal efficiency is equal to 1 minus CB over T5 minus T1 all over CB multiplied by T3 minus T2 plus CP multiplied by T4 minus T3. And that's all. Next slide po.
Yan, so ito naman yung mga other cycles na nagpe-perform ng 2 isothermal heating. Yan, so itong tatlong to is same efficiency siya as Carnot cycle. Pero hindi pa rin siya as efficient as Carnot cycle kasi merong limits yung kanyang temperature. Yan, so itong tatlo ding to, Carnot, Stirling, saka Ericsson cycle are all external combustion engine. Yan. And yan, itong tatlong to is ang kanilang mga working fluid is hydrogen and yan helium. Yan. So medyo mag-dive deeper muna tayo sa Carnot cycle. Yan. So ito yung TS diagram ng Carnot cycle, itong nasa pinaka left side. And so ano nga ba yung Carnot cycle? So ang Carnot cycle is an ideal heat engine cycle. So ang naka-imbento nito ay si Nicolas Leonard Sadi Carnot. Isa siyang French military engineer. And because dito sa mga contribution ni Carnot is kinonsider siya bilang father of thermodynamics. Kasi yung mga works niya is siya yung naging pinakang foundation para mabuo yung second law of thermodynamics. Yan. So, ang Carnot cycle is composed siya ng four processes, two isothermal saka two adiabatic. So, itong first, yung process 1 to 2, ito yan, yung 1 to 2, isa siyang reversible isothermal gas expansion process. Yan. In this process, the ideal gas in the system absorbs yung Q in, yung amount of heat from a heat source at a high temperature. And then, dahil doon is yung ating gas is nag-expand. Process 2 to 3 naman is a reversible adiabatic gas expansion. And yan, in this process, the system is thermally insulated, meaning na walang pumapasok or lumalabas na heat. And all temperature changes only occurs inside dun sa system. Ayan. And process 3 to 4 naman is a reversible isothermal gas compression process. And in this process, surroundings do the work to the gas and cause a loss of heat. Ayan. And yung last naman is process 4 to 1 is a reversible adiabatic compression. Ayan, so after nung 4 process na yan is mag-e-end tayo sa process 1 to 2 ulit, and yun, that's make it a cycle. And yan, so sabi dito is Carnot is the most efficient cycle, pero bakit nga ba? So number 1 is it uses the ideal gases. Yan, it is also a perfect engine, meaning it has no friction in its cylinder and walls, and it also has no heat transfer. And all of its process are also all reversible. Pero the problem is all those things don't exist in the real world, and ibig sabihin lang nun is impossible siya ma-replicate sa mundo natin. Pero that does not mean na yung Carnot cycle is wala na siyang use. Ang Carnot cycle pa rin ang pinakang naging basis ng lahat ng mga cycle, yung mga nabanggit kanina, na ating ginagamit sa ating pang-araw-araw ngayon. Ayan. So, yan. Next natin naman is Stirling cycle. Yan. So, Stirling cycle is a thermodynamic cycle that describes the general class of Stirling devices. This includes the original Stirling engine that was invented, developed, and patented in 1816 by Robert Stirling. And kasama na rin yung tulong ng kanyang brother, which is also an engineer. Yan. So, just like Carnot cycle, ang ating yan. And so just like Carnot cycle is ang Stirling cycle is composed also of 4 processes. And the main difference naman, and sabi dito is, ang main difference lang ng Carnot cycle dito sa Stirling at Ericsson cycle naman is yung kanyang 2 processes. Yan, so tignan natin kung ano yan. So, meron siyang 4 processes. Yung process 1 to 2 ng Stirling cycle is isothermal heat addition. Yan. So, dito nag-expand and nag-add tayo ng heat. Process 2 to 3 naman is isochoric heat removal. Yan. Which is a constant volume naman yan. And process 3 to 4 is isothermal heat removal. And process 4 to 1 is isochoric heat addition. Yan. So, Stirling engines are energy conversion device. Yan. So, ito yung application pala ng Stirling cycle. Yan. Stirling engines are energy conversion devices used as prime movers, refrigerating engines, or heat pumps. Currently, they are used commercially as cryogenic cooling systems and are under development as low-noise, low-emission automotive engines. Yan. Next naman is yung ating Ericsson cycle. So, Ericsson cycle is named after inventor John Ericsson. Siya yung marami siyang na-design na unique na heat engine and nabase sa mga iba't ibang thermodynamic cycle. So, katulad din ng dalawang naunang cycle na nabanggit ko is composed din siya ng 4 na processes. And yung process 1 to 2 is isothermal compression, process 2 to 3 naman is isobaric heat addition, process 3 to 4 is isothermal expansion, and process 4 to 1 naman is isobaric heat removal. So, para mas madali nating matandaan is ang Carnot cycle ay ang kanyang matatandaan natin siya sa mnemonic na ano nga ba? 'Di ba nag-start siya ng isothermal, then adiabatic, isothermal, then adiabatic. So, matatandaan natin siya as TSTS. So, isothermal, adiabatic, isothermal, adiabatic. So, yung S is also stand for isentropic. So, Stirling cycle naman. Yan. Pa-next na nga slide. Yan. Mas maaalala natin siya as TVTV. So, isothermal, then isochoric, isothermal, then isochoric. Yan. Tapos para naman dito sa Ericsson cycle, is mas madali na, ito is medyo nagkamali lang, pero sa totoo is siya talaga ay PT-PT since nag-start siya sa isobaric processes. Sa isobaric process. Yan. So, yan, dito nga pinakita na ang pagkuha ng thermal efficiency ng Stirling cycle at saka Ericsson cycle is the same lang as Carnot cycle. Pero yun na nga, hindi pa rin siya as efficient as Carnot engine. Ayan. So, next na din. Ayan. So, Brayton cycle. So, ayan. So, ang Brayton cycle is a gas power cycle by George Brayton in 1870. So, para sa diagram niya is nagko-consist siya ng isang compressor, a heat exchanger, a turbine, and another heat exchanger drawn as dash line. Yan, so ang pinaka-typical application for this cycle are the gas power plants and aircrafts. Ayan. So, ang ating Brayton cycle naman is nagko-compose siya ng 4 din na processes. Process 1 to 2 is isentropic compression. Process 2 to 3 naman is constant pressure heat addition. Process 3 to 4 is isentropic expansion. And process 4 to 1 is a constant pressure rejection. So, ito yung mga formulas natin for Brayton cycle. So, ito. Yung R sub P quantity is equals to K minus 1 over K is equals to T2 over T1. Tapos para naman sa ating work na papasok is mass times specific heat capacity with constant pressure times the change in temperature of from 1 to 2. Yan, so ito naman W sub T is same lang din siya pero naiba lang yung ating temperature. And yung ating heat added is yung ating namang mass times specific heat capacity times the change in temperature in processes 2 to 3. Yan. And ang ating cycle efficiency is equals to E is equals to 1 minus 1 over R sub P raised to K minus 1 over K. Yan. So, ang ating backwork ratio is equals to W sub C divided by W sub T. Yan. At saka for maximum theoretical network is temperature 2 is equals to the square root of T1 multiplied by T3. Yan. So, also equal din siya sa T2 equals T4. Yan. So, next. Ayan. So, ito yung pinakang summary ng lahat ng gas power cycles. And para mas madali natin siyang matandaan is pwede natin gamitin yung mnemonic na Deber SC load. Yan. So, yung D, nag-i-stand siya for diesel. Yung B stands for Brayton. E stands for Ericsson. R stands for Rankine. S stands for Stirling. C stands for Carnot. L stands for Lenoir. O stands for Otto, A stands for Atkinson, and D stands for Dual. So, yan yung ating gas power cycle, D, Ber, SC load. At saka, yan, mas matatandaan natin siya dito sa mga mnemonics na to. So, yung S, nag-i-stand siya for isentropic. P naman is nag-i-stand siya for isobaric. V stands for isochoric. And yung T naman is nag-i-stand siya for isothermal. Yan, so pag halimbawa sa diesel, kung ayan, ang ating mnemonic para dyan ay SPSV, edi yung cycle niya ibig sabihin is nag-i-start sa isothermal, then isobaric, then isothermal, may isentropic, then isobaric, isentropic, then isochoric. Yan, so dito mas madali natin siyang matatandaan and yun. Nakalagay din dito kung sino nag-invent sa kanya. So, ang nag-invent ng diesel is Rudolf Christian Carl Diesel. Yan. Sa Brayton naman is SPSP. So, ibig sabihin, siya is isentropic, isobaric, isentropic, isobaric. Yan. Parang nabanggit na rin to ni Sir sa kanyang mga discussion. Yan. So, ang inventor ng Brayton cycle is si George Bailey Brayton. Then, ano naman tayo? Sa Ericsson, so PT-PT siya. So, ibig sabihin, ito is isobaric, isothermal, isobaric, isothermal. And yung kanyang inventor is si John Ericsson. Then, ganun din naman sa Rankine, SPSP. Yan, so di ko napapaulit-ulitin. And yan, so ang kanyang inventor is si William John McCorn Rankine. And sa Stirling naman is TVTV. Yan, dito nagkamali lang ng inventor, nagkabaliktad yung kay Stirling sa yung kay Carnot. So, para sa Carnot cycle is STST. So, kay Nicholas Leonard Sadi Carnot yan. And yung Lenoir, hindi siya na-discuss. Pero in-include na rin siya. So, sa cycle ng Lenoir cycle is VSP by Jean Joseph Etienne Lenoir. So, Otto cycle ay SVSV and ang kanyang inventor is si Nicholas August Otto. And para sa Atkinson, SVP naman kay James Atkins, naman siya, para kay ang inventor niya is si James Atkinson. And for dual cycle is SVPSV naman. And ang nag-invento ng dual cycle is si Gustav Trinkler. And yun na po ito ang pinakang summary ng all gas power cycles. Yeah. So thank you.
Good day po, ako po si Neil Ivan Orlanes. Ang i-discuss ko po ay steam power plant. What is a steam power plant? A steam power plant consists of a boiler, a steam turbine, a generator, and other auxiliaries. The boiler generates steam at high pressure and high temperature. The steam turbine converts the heat energy of steam into mechanical energy. Ang steam power plant ay conversion of the high temperature and pressurized geothermal fluid to steam and brine. It consists of a boiler, a turbine, a generator, and other auxiliaries. The purpose of the boilers is to generate steam at high pressure and high temperature, and on the other hand, the steam turbine converts the heat energy of steam into mechanical energy. Yung nasa baba kong picture ang representation of steam power plant. Next po. Steam power plants may play a key role in supplying electrical energy. In addition to electricity production, some steam power plants use part of the heat generated to supply district heating. This is why the Rankine steam cycle is still one of the most important industrially used cyclic processes today. In a steam power plant, a steam turbine driven by steam generates mechanical energy. A generator then converts this mechanical energy into electrical energy. The steam required can be generated from nuclear energy, fossil fuels, solar energy, or geothermal energy. For example po is steam power plants essentially have the same design. Heat source, steam generator, turbine with generator, and cooling. For additional information, power plant has a massive role in supplying electrical energy. Some steam power plants are used to use part of the heat generated to supply district heating. This is why the Rankine steam cycle is still one of the most important industrially used cyclic processes today. Ang steam turbine na driven by steam used to generate mechanical energy. A generator then converts this mechanical energy into electrical energy. Next po. Yung mga picture po ay ang some types of steam power plant, and to distinguish different types of this, it must be according to the heat source that provides the thermal energy. The following types. Meron po tayong nuclear power plant, coal-fired power plant, oil-fired power plant, solar thermal power plant, gas and steam turbine power plant. Theoretical fundamentals of the cyclic process of a steam power plant. The cyclic process used here is the Rankine cyclic process, which was used to assess, evaluate, and compare steam power plants. This thermodynamic cyclic process describes the conversion of thermal energy into mechanical energy and vice versa. It is widely used by power plants used as coal-fired power plants or nuclear reactors. In this mechanism, fuel is used to produce heat within a boiler, converting water into steam which then expands through a turbine, producing useful work. In addition, there are four processes in the Rankine cycle. Furthermore, in steam power plants, first the thermal energy of a working medium is converted into mechanical energy. To this end, the working medium is alternately condensed at low pressure and evaporated at high pressure. The pressure is applied by the feed pump through expanding work and reduced in the turbine while releasing work. The working medium is carried in a closed circuit. Next po. Ang picture po na nakikita natin sa bandang taas ay ang setup or design of steam power plants. Basic elements of power plant. Steam generator. Combination of apparatus for producing, furnishing, or recovering heat together with apparatus for transferring to a working fluid the heat thus made available. It indicates the furnace, boiler, water walls, water floor, water screen, superheater, reheater, economizer, air reheater, and fuel burning equipment. The term boiler has been used for such a long period of time that the two terms are used interchangeably. Steam turbine. It is a practical power source when built in as small as 5 horsepower or as large as 100,000. It is relatively quiet and smooth in operation. Condenser. A heat exchanger where steam enters the top and the condensate is collected in the hot well at the bottom while cooling water flows through the tubes. Boiler feed pump or feed water pumps. Its function is to increase the pressure existing on a liquid and increment sufficient to the required service. Uh, Rankine cycle. Rankine cycle is presented from this slide. The critical point down to saturated liquid and subcooled liquid. On the other side, from critical point down to saturated vapor or superheated vapor. Also in this picture, quality was also presented where H sub 2 equals H sub F2 plus XH sub F3. Next po. TS diagram. This diagram represents the Rankine cycle of a steam power plant. The working medium is water or water steam. 1 to 2, the water is isobarically heated and evaporated in a steam boiler at a pressure of 22 bar. 2 to 3, isobaric superheating of the steam to 300 degrees Celsius. 3 to 4, polytropic expansion of the steam in the steam turbine to a pressure of 0 to bar. Mechanical energy is released in the process. Point 4, wet steam area, the wet steam content is now only 90%. 4 to 5, condensation of the steam. 5 to 1, increase the pressure to boiler pressure via the condensate and feed water pump. The cyclic process is complete. Next po. In this part, the ideal and actual diagram of a steam power plant was also shown. Also, the schematic diagram and its process. The process is 1 to 2 isentropic expansion, 2 to 3 isobaric heat rejection, 3 to 4 adiabatic pumping, 4 to 1 isobaric heat addition. Next po. Reheat cycle. Schematic diagram. Ang process po ay 1 to 2 is centropic expansion, 2 to 3 isobaric reheating, 3 to 4 isentropic expansion, 4 to 5 isobaric heat rejection, 5 to 6 adiabatic pumping, 6 to 1 isobaric heat add. Regenerative cycle. Ang process po ay 2 to 6 constant pressure heat rejection in reheater. 4 to 5 adiabatic pumping, 6 to 7 adiabatic pumping, second stage. Next po. To elaborate, regenerative cycle is a cycle in a steam engine using heat that would ordinarily be lost, and it is process where the heat is extracted between the turbine stages and used to heat water coming from the condenser, increasing the temperature of feed water to the boiler. Next po. Regenerative cycle. We have two types. Open feed water heater is direct contact heater and steam and water mix. And closed feed heater heat exchanger that can operate at either high or low pressure, and there is no mixing of the water and steam in heater. Feed feed water heater is a heating system that uses steam to increase the temperature entering the boiler. Combined gas turbine steam cycle is used to transfer heat carried by the flue gas in the gas turbine cycle to the feedwater in the steam cycle. The heat exchanger performs the function of a boiler. Next one. Binary mercury steam power plant is used to transfer heat carried by the mercury in the mercury vapor cycle to the feedwater in the steam cycle. The heat exchanger performs the function of a boiler. Next. Cogeneration steam power plant. Cogeneration is the production of more than one useful form of energy, such such as process of heat and electric power from the same energy source. Common examples of cogeneration application include pulp and paper mills, steel mills, food and chemical processing plants, and district heating application. Additional information: Rankine cycle power converts 26% of the heat it receives in the boiler to net work. Only 0.4% of the turbine work is required to operate the pump. The highest steam temperature allowed to the turbine inlet is about 620 degrees Celsius. Ceramics are very promising in this regard. In a reheat cycle, the optimum reheat pressure is about one-fourth of the maximum cycle pressure. A trap the allows the liquid to be throttled to a lower pressure region but traps the vapor. Binary cycle is composed of two separate cycles, one at high temperature and the other at relative low temperature. Combined cycle have a higher thermal efficiency than the steam gas turbine cycle. Steam is not an ideal gas. Steam
Um,
generator, commonly referred as boiler, is an integrated assembly of several essential components, the function of which is produce steam at a predetermined pressure and temperature.
I am Paul Henry Citan, the reporter in this topic. So steam generator, commonly referred as boiler, is an integrated assembly of several essential components that function of which is to produce steam at a predetermined pressure and temperature. So i-explain ko po muna itong picture na nasa left side natin. So, kung paano ang flow ng feed water natin, steam at ng waste heat natin. So, sisimulan ko muna sa feed water. So, galing sa pump, dadaan siya sa ating economizer papunta sa ating steam drum. Bababa sa ating downcomer, sabay papunta ulit, pataas ulit sa ating water wall. So, sa water wall natin, ang nangyayari yung evaporation dahil sa ating burner. So, magpo-produce na siya ng steam papalabas at papunta ng turbine. So, ang waste heat naman natin or hot gases ay dadaan sa ating economizer. So, ang purpose nga po pala ng economizer ay dahil isa lang ang daanan ng feed water at waste heat. So, bago pumasok ang feed water sa ating steam drum ay mainit na to. So, pagkatapos sa economizer natin ay dadaan na siya sa ating chimney papalabas. So, sa ating right side naman natin, so fuel and air sa ating furnace para mag-combust. Sabay feed water ang ibuboil natin na magpo-produce ng steam. So, next slide po. So, different types of boiler po. Boiler or steam generator. A closed vessel intended for use in heating water or for application of heat to generate steam or other vapor to be used externally to itself. Unfired pressure boiler. A vessel in which pressure is obtained from an external source or from an indirect application of heat. Power boiler. Steam is generated at a pressure of more than 1.055 kilograms centimeter square gauge by the direct application of heat. Locomotive boiler. Mounted on a self-propelled truck locomotive and used to furnish motivating power for traveling on rails. The portable boiler. An internally fired boiler which is self-contained and intended for temporary location. So, miniature boiler. It is a power or high temperature water boiler that does not exceed the size and pressure limits specified. Yeah. So, ang diameter ay 405 mm, length is 1065 mm, ang working pressure limit ay 7.03 kg centimeter square. Low pressure, maximum of 1.055 kg centimeter square gauge, and the temperature is 121 Celsius. Medium pressure, maximum is 103.5 megapascal gauge, and the temperature is 130 Celsius. Hot water supply boiler. Furnishing hot water to be used externally to itself. Second-hand boiler. A boiler or unfired pressure vessel where both the location and ownership have been changed after primary use. Reinstalled boiler. Removed from its original setting and re-erected at the same location or erected at a location without change of ownership. Condemned boiler. Declare unsafe to operate. Oil-fired. Uses bunker C as fuel. Next po. Ito po yung parts ng ating steam generator. Pressure parts, the boiler, heating surface, tubes with attached drums or shells for storage of water and steam. Superheated surface provides more heating surface through which the steam must pass after leaving the boiler if a final superheated state is desired. Economizer is a feed water preheating device which utilizes steam mixed with the feed water. Enclosure or setting. Water walls. Water tubes installed in the furnace to protect furnace against high temperature. Serves as extension of heat transfer area for feed water. Furnace. Encloses the combustion equipment to utilize effectively the heat generated. Combustion equipment. Burner. Used in fire tube boilers for firing liquid and gaseous fuels. Stoker. Used in water tube boilers for firing solid fuels. So, auxiliaries and accessories. The air preheater. Utilizing the heat of the flue gas to preheat the air needed for combustion. Forced draft fan. Forces air inside to support fuel combustion. Induced draft fan. Situated at the bottom of the chimney or smokestack. Extract flue gases out. Soot blower. Removes soot around steam pipes. Employs the use of extracted steam from the main steam line. Blow down valve. Impurities that settle in the mud drum are removed, also called the blow-off valve. Breaching, duct connecting boiler to chimney. Baffles, direct the flow of the hot gases to effect efficient heat transfer. Fusible plug, a metal plug with a definite melting point through which the steam is released in case of excessive temperature, which is caused by lower water level. Safety valve, safety device which automatically releases the steam in case of overpressure. Next. So, computations, formulas. Boiler heating surface. So, para daw makuha yung heating surface, ang kailangan daw ay 1/2 daw ng area of shell plus the inside area of all our tubes plus the 2/3 of the rear head area minus cross-sectional area ng ating tube sections. So, the rated boiler horsepower. So, dalawa, water tube tsaka fire tube boiler. Para sa ating water tube boiler, kailangan natin yung heating surface inch meter square all over 0.91. Sa ating fire tube, same lang na bago lang yung denominator, naging 1.1. So, develop boiler horsepower. Para makuha ay kailangan ng mass of steam natin, entropy ng steam minus sa entropy ng ating feed water all over sa 35,322. So, percent rating. So, para makuha ang percent rating, develop ng boiler horsepower natin all over sa rated boiler horsepower. Ating ASME evaporation units, para makuha ay mass of steam, open parenthesis, entropy ng ating steam, subtract sa entropy ng ating feed water. Factor of evaporation. Entropy of steam minus entropy of feed water all over 2257. So sa ating equivalent evaporation, mass of steam times sa ating factor of evaporation. Sa ating namang actual specific evaporation, mass of steam all over the fuel mass flow. Sa ating equivalent specific evaporation, mass of steam all over the fuel mass flow times sa ating factor of evaporation. Next po. Boiler efficiency or overall thermal efficiency. Measure of ability of boiler or steam generator to transfer heat given by furnace to water and steam. So, para makuha ang formula sa ating boiler efficiency ay mass of steam, open parenthesis, entropy ng ating steam minus entropy ng feed water plus the mass of reheated steam, open parenthesis, sa ating heat leaving minus the heat entering. So plus sa ating mass ng ating water blowdown, open parenthesis, sa the heat leaving minus the entropy of our feed water. So, pag wala naman daw, if no heat, reheater and boiler blowdown, yan naman daw yung ating formula sa so, net boiler efficiency. Para daw makuha, so the mass of steam sa ating entropy of steam minus entropy ng ating feed water minus sa power consumed by the auxiliaries sa ating sa all over the fuel mass flow sabay times sa ating higher heat temperature. Boiler and furnace efficiency. mass of steam, open parenthesis, entropy ng steam minus HF all over MFQH minus the ating amount of ash required at UAsh. Ang HHV po ay higher heating value. Rate efficiency is equals to 1 minus amount of carbon in the fuse or ash times QC. QC is higher heating value of our combustible all over the higher heat temperature. The next po. The boiler blowdown is the removal of water from a boiler. Its purpose is to control boiler water parameters within prescribed limits to minimize the scale corrosion carryover and other specific problems. Superheater is a heat exchanger that is used to increase the total energy of the steam. The superheater used to decrease the energy of the steam and is done by injecting water or passing the steam in a closed system. So sa diagram natin, simula po tayo sa ating fuel input, ash. So sabay sa ating feed water na galing sa pump dadaan sa economizer papunta sa ating steam drum, which doon na magproduce ng steam papunta sa ating turbine. So, ang waste heat natin ay dadaan sa economizer papuntang air preheater sabay chimney. So, ang purpose daw po ng air preheater ay para sa dadaan na air ay hindi na siya dahil doon dadaan yung waste heat, ang lalabas na air papunta sa ating furnace ay mainit na. So, parang mas mapapabilis natin yung pag-init ng boiler. Yun lang po. Thank you.
So, steam turbine. Steam turbine is expansion of steam through numerous stages in the turbine process converts the heat energy of steam into mechanical work. So, ang steam turbine ay prime mover ng thermal energy ng steam na nagtatransform into kinetic energy at yung kinetic energy ay nagtatransform to mechanical energy. So, ang steam turbine ay isa sa pinaka ginagamit o mas kilala na prime mover for large power generator. So, cylinder arrangement. A single cylinder with all rotating blades attached to one shaft and the steam flow all in one direction. So, siya yung una na nagfo-flow lang daw siya sa iisang direction. Double flow units, single cylinder unit with steam entering in the center and flowing in two equal quantities but in opposite direction along the shaft. So, ito naman daw po yung kasunod, yung may bilog na kabila na yung steam daw po ay papasok sa may gitna tapos dalawa yung nilalabasan yung sa dalawa nalabas yung flow pero in opposite direction. Tandem compound units, single flow high pressure turbine connected to a double flow low pressure turbine. So siya daw yung nagko-connecta sa dalawa. Cross compound units differ from tandem compound units only in the high and low pressure ends are not in the same shaft. Steeple or vertical compound units. Next. So, principal parts, um, rotor. Rotor is the main moving element of a turbine. Casing, principal stationary element. It surrounds the rotor and holds internally any nozzles, blades, and diagrams that controls the path and physical state of the expanding steam. Bearings, two main bearings placed outboard of the shaft seal. Shaft seals prevents the outflow at the high pressure end and airflow at the vacuum end. Steam control regulate the flow of steam to produce constant rotative speed in the presence of variable power demand. Oil system lubricates the bearings. Next, next po. So, sabi dito, according to steam action, yung steam turbines are mainly classified into two types. Ito ay impulse turbine at reaction stages. So dito sa impulse turbine ay consist of a stationary nozzle with rotating buckets or blades. So dito nga ito yung nagko-consist siya ng fixed nozzle saka bucket. The steam expands in the nozzle. So nangyayari dito ay yung impulse turbine ay parang kutsara at yung nozzle siya yung nagre-regulate ng steam flow at ginaguide niya yung steam sa appropriate velocity. So bali paglabas ng high pressure energy ng steam dito sa fixed nozzle ay nagtuturn siya sa kinetic energy. So yung high velocity na nalabas sa fixed nozzle ay yun yung nagpapaikot ng bucket blades. Tapos na may nakakonect siyang shaft papunta sa generator na nagpo-produce ng energy. So ang kilalang impulse turbine ay Pelton and cross flow turbine. Velocity compound stage involves a stationary nozzle followed by several rotating and stationary buckets. The nozzle has a large pressure drop with a resulting increase in velocity. Pressure compound stages or Rateo stage involve several sets of nozzles with small pressure drops through each set of nozzles and complete velocity dissipation in each row of rotating buckets. So ito naman yung isa pang types ng steam action ng steam turbine is reaction stages. Reaction stages are composed of one stationary row of blades and one rotating row of blades, with a pressure drop occurring in each stationary and rotating row. The steam expands in the blade. So, ang nangyari naman dito ay parang rin, kaso itong reaction stage, yung nozzle niya, siya yung naikot. Dito nagko-consist yung moving nozzle, di katulad nung